Okay, we are going to learn how to graph sine and cosine graphs. Sine and cosine graphs. If you were asked to graph y is, say, equal to the sine of x minus pi. There's an understood plus sign in front. So we're graphing a positive sine graph. The nice thing about it is we could graph it. That's a positive sine graph. And we'll put the values in next. Now we're going to put the values in. You start a sine graph. That is, you start right there. You start a sine graph wherever the angle is equal to 0. Well, if you subtract two quantities and you get 0, you should immediately say, oh, they're equal. Pi minus pi equals 0. So we start at pi. Okay, that's done. Where do we finish? And for all sine and cosine graphs, we start where the angle is 0, and we finish where the angle is 2 pi. If you add pi to both sides, you'll get the answer. On the left side, minus pi plus pi cancels, you just have x. The right side, 2 pi's plus pi, or 1 pi, is 3 pi. You should know that if you have 3 pi's and you take away 1 pi, you'll have 2 pi. This, I hope, is clearly 3 pi. Okay, but we worked it out more mechanically, and we got that the finish is at 3 pi. Okay, I'm going to jump on that, 3 pi. This is understood to be 1 pi. Be very nice if we can find the quarter values, these 3 values. Let's find the middle first. Let's find that one first. Well, forget pi's for now. 1 pi and 3 pi. Think 1 and 3. What's in between 1 and 3? 2. 2 what? 2 pi's. This value is in between 1 pi and 2 pi. Just think 1 and 2. Whatever I get, if I get what's in between 1 and 2 is 11, I'll say 11 pi. If I get 0.93, I'll say 0.93 pi. Whatever I get between 1 and 2, whatever I think it is, I'll tag on pi. What's in between 1 and 2 is 1.5. And if you don't know that, just add them up and divide by 2. You get 3 over 2, or 1.5. So what goes here is 1.5 pi, 3 pi over 2. Now we're going to try to find this value. Well, that's in between 2 pi and 3 pi. Well, forget pi. We know it's going to be pi. 9 pi, 3.5 pi, 2.8 pi, some number of pi. Well, what's in between 2 and 3? Dead center in between. That's called the average. Add them up, divide by 2. 2 plus 3 is 5 over 2. It's 5 pi over 2. It's 2.5. 2.5 is 5 halves. Okay. Now, so we found the start, we found the finish, we plotted the 5 values. The start, the finish. We plotted the start, the finish, the middle point, and then the other quarter points. 5 points you should write down. Now, due to lack of space, I want to erase the start and the finish, because there is one thing I didn't put down, and that's called the y-axis. Now, the x-axis goes to the left forever. So, where should the y-axis be? Well, we know that we're at pi right here, we're at pi right here, we need to go pi to the left. And that will bring us to 0. Now, what you should notice is that this piece went from 1 pi to 2 pi. Well, that's pi. That's a length of pi. That is, this distance is pi. Oh, I'll go the same distance to the left, and there's my y-axis. There's my y-axis right here. Now, one more thing we need to do. There's an understood 1 in front. That is, the highest value is 1, the highest value is 1, and the lowest value is negative 1. Now, to be honest, I didn't graph y equals sine of x minus pi. I graphed 1 period. Graph 1 period. That's all you're usually going to be asked to graph. What am I saying? So first, let me redraw this and then I'll say what I'm saying. Sine graphs and cosine graphs go left and right forever. They just go on and on and on and on. What we graphed was 1 period. We graphed this. And we did a fine job at it, and that's what counts. But nonetheless, this keeps going on to the right forever, and it keeps going to the left forever. That is, somebody in your class, instead of drawing what we have in black here, somebody else could have said, you know what? I'm going to draw that 1 period. Okay? It's in green, but for some reason it doesn't look like it. Someone can say, here's my 1 period, and they'd be completely correct. Another student can say, wait a minute, wait a minute, wait a minute. This is my 1 period. And everyone will be right. Everyone will be right. The blue person, the green person, the black person, and if I go all the way to the left, over here, you can't really see that, but now you have the red person. The person who draws in red, they're also correct. Draw 1 period. What we did, fine. Be more complicated to find the green one or the blue one or the red one. Graph 1 period. And whenever I say graph, I always mean 1 period from now on. Because you can't graph it because it'll take you the rest of your life. It goes on to the right forever. And once you're done graphing it to the right forever, you're not going to believe it because now you have to graph it to the left forever. So now we're asked to graph y is equal to 4 times the cosine of x plus, say, pi over 2. We're asked to graph this. Well, since it's a positive cosine graph, 4 is positive, I draw a cosine graph. Here it is. In the end, I'm going to want to know where the start is, where the finish is, and the quarter values. Those are the 5 values I'm going to want to find. But the nice thing is that it's already graphed. You get full credit for graphing it. There it is. Okay, now it starts wherever the angle, and you take cosines of angles. It starts whenever the angle, x plus pi over 2, is 0. Take away pi over 2 from both sides, and that will leave you on the left side with x. And 0 take away pi over 2 is negative pi over 2. Okay, we now know the start. It's negative pi over 2. The finish, F for finish, it finishes whenever the angle is equal to 2 pi. Okay, now you should anticipate taking away pi over 2. And pi over 2 is over 2. So when you subtract, you need all denominators to be the same. So think of 2 pi as something over 2. Well, 2 times 2 pi, that's 4 pi. It's 4 pi over 2. So no more 2 pi. We're going to think of 2 pi is 4 pi over 2. The angle is equal to 2 pi. Just another way of writing 2 pi. Whether you do it at the beginning, the middle, or the end, you're going to have to change it to 4 pi over 2. Might as well do it at the very beginning. Because in order, in the left side, you take away pi over 2, no problem at all. You just get x. But when you take away pi over 2 from the right side, the denominators have to be the same. And what do you know? They are. The numerators, 4 pi minus pi is 3 pi. This graph ends as 3 pi over 2. Now, let's find the middle. Now, if you follow what I'm saying, I'll give you the cleanest way of doing this. The cleanest way of doing this is a way that doesn't involve the complicated part. First of all, negative pi over 2 is negative 1 pi over 2. Pi over 2 is common. And in every one of these, we're going to have some number times pi over 2. For example, if we have 6 times pi over 2, we might be able to simplify that. But nonetheless, we're going to come up with a number times pi over 2. We are going to ignore the hardest part of this. We're going to ignore pi over 2. What's in between negative 1 and 3? Well, if you add them up and divide by 2, you get 2 over 2 or 1. That is, you get 1 pi over 2. You get 1 pi over 2. Okay, get 1 pi over 2. Now, let's find this middle point here. This is in between negative 1 pi over 2 and positive 1 pi over 2. Ignore the pi over 2's. What's in between negative 1 and 1? It's 0. If you're going to insist you don't know that, fine. Add up those two numbers, divide by 2. Negative 1 plus 1 is 0. And 0 over 2 is not 0 over 2. It's 0. So in the middle, you get 0 pi over 2. But that's 0. The nice thing about getting 0 on the x-axis is now we know exactly where the y-axis is. Okay, now we need to find this quarter point here. It's in between negative 1 pi over 2 and 3 pi over 2. Ignore the pi's over 2. What's in between 1 and 3? You really should know that. But if you're going to say you don't, hey, I don't believe you, but let's play the game. 1 plus 3 is 4. You add up the numbers, divide by 2. So you get 2 pi over 2. I'm in the top right now. You get 2 times pi over 2, and coincidentally the 2's cancel out, so you get pi. So you put pi right there. Okay. Last thing. Since the number in front is 4, the highest value is at 4, and the lowest value is at negative 4. There's your graph. I graphed it first, then I fill in the x values and the high and the low point. Let's try another one. Let's try another one. Suppose you were asked to graph y is equal to negative 2 sine of 3x minus pi. Since this number in front is negative, I'm going to draw my sine graph upside down. Normally, it goes like that. I'm just going to draw it upside down. There's my graph. The dotted lines, the dotted graph really shouldn't be there. Okay, there's your graph. Okay, done. Get part credit for that. You drew the graph. Okay, now we start whenever the angle 3x minus pi, you take sine of angles. Whenever the angle is 0. Well, if this minus this is 0, then this equals that. 3x must be pi. Pi minus pi is 0. This must be pi. Pi minus pi is 0. Nothing else minus pi gives you 0. Okay, divide by 3 to get x alone. And now we have the start. It's pi over 3. Beautiful. Pi over 3. Done. Now that's for the start. For the finish, you take the angle and you let it equal to 2 pi. Well, I hope you realize that should be 3 pi. 3 pi minus pi is 2 pi. Okay, if you don't want to do it that way, add pi. But 3 pi, and it has nothing to do with what's in this circle. If you have 3 pi's, 1 pi, 2 pi, 3 pi, and you take away pi, you'll be left with 2 pi's. And that's what it's saying. 2 pi plus 1 pi is 3 pi. 3 times x, 3 times some number, is equal to 3 times pi. Well, you should know that 3 times pi equals 3 pi. X should be pi. And if you divide by 3, you'll see it. The left is x when you divide by 3. The right side is pi. 3x is equal to 3 times pi is asking. It's asking the following. What goes in this box? Instead of x, you write box. 3 times y equals 3 pi. Well, 3 times pi equals 3 pi. Nonetheless, it finishes at pi. It finishes at pi, at 1 pi. Now, the start is over 3. The right is not. But you should realize that 1 is 3 over 3. That is, right now, they both have pi over 3. 1 pi over 3, 3 pi over 3. So to find the middle, we know it's going to be pi over 3. How many? What number is in between 1 and 3? 2. 1 plus 3, add them up, divide by 2. You find the average of two numbers, you find a number in the middle. So here we have 2 pi's over 3. Now let's go and find this value. Again, we know it's some number times pi over 3. Well, what is that number? What's in between 1 pi over 3 and 2 pi over, what's in between 1 and 2? 1.5. What's in between 1 and 2? Add them up, divide by 2. It's 3 over 2. 3 over 2 what? Multiply all answers in this problem by pi over 3. Coincidentally, those 3's cancel out, and you get pi over 2. Okay, pi over 2. What goes here? Well, it's the average of 2 pi over 3 and 3 pi over 3. We know it's pi over 3. What's in between 2 and 3? What's in between 2 and 3 is 5 halves. So what do you get? You get 5 halves. Pi over 3. 5 times pi over 6. You get 5 pi over 6. Okay? So you don't get a number times pi over, well, the number times pi over 3 is 5 halves. times pi over 3. But that happens to give us something over 6. And there it is. Pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and 1 pi, or just pi. And here is your x-axis. Okay, I need to erase, well, before I erase the start, there's another name for the start. It's called the phase shift. If you just find out where the angle equals 0, you will have the phase shift. If you find out where the angle equals 0, you'll have the phase shift. Okay, now there's something called the period. Now, I guess there's two definitions for period. The period, when they say find the period, they mean the length of a period. What is this length? Well, the length is always going to be the finish minus the start. The period is going to be the finish, which we found out to be pi, minus the start, which we found to be pi over 3. And if we work this out, pi is 3 pi over 3 minus pi over 3. Now the denominators are the same. We keep it, subtract the tops. 3 pi minus pi is 2 pi. The period, if they say draw a period, they're asking you to draw a portion of the graph. If they say find the period, they're asking for the length of that period. Well, if you want to find how far it is from 7 to 10, you do 10 minus 7. And that gives you that distance. Do the right endpoint minus the left. That's what I did. 1 pi minus pi over 3. What did I get 1 pi from? It came from the finish. The finish was at pi minus the start, which was pi over 3. Okay, the phase shift is the start value. Where do you start? Set the angle equal to 0. The length of the period, or the period, is the finish minus the start. Okay, like I was about to say, if I didn't say it, I need to erase part over here because I need to figure out where the where the y-axis goes. Okay, since it starts at a positive value at pi over 3, zeros to the left of every positive number. Zeros to the left. So I know that the x-axis is somewhere to the left. Now we need to think. Since I drew on this so much, let me draw it again. In particular, this is pi over 3, 1 pi over 3, and here it said 2 pi over 3. That means this distance from 1 to 2 is 1. 1 what? 1 pi over 3. This distance is pi over 3. Well, that's exactly how far to the left of pi over 3 I expect to find 0. So nobody's going to take a ruler out, but you should try your best to go that distance to the left of that point. Don't go out here and say the y-axis is here. Go approximately that distance. Here's the y-axis. That is, I'm going to try to go approximately this distance. And there's the y-axis. Okay. Like always, there's that one last step at the end, and that's labeling the y-axis. Once you draw the y-axis, then you should be able to label it. Always ignoring the sign in front. The highest value in our case is 2. The lowest value is negative 2. I must admit that 2 should be a little bit higher, but I ran out of space. In fact, let's do it exactly right. Let's erase the equation. Erase this here. And the highest value should be 2. And the highest value comes from right here. From right here. That's the highest value. So you shouldn't really put these dashed lines, but you should look straight across and put 2. Go to the highest value and imagine where you'd be if you went across. Find the lowest value, which is right here. Go across and put -2. Let's try one more, please. Suppose you were asked to graph y is equal to -1/2 cosine of 3x plus pi. 3x plus pi. Okay. Since it's a negative number in front, I draw my cosine graph upside down. Upside down. There it is. Graph is done. The lowest value should be the same though, the same height. Okay, I should have come down a little bit more. Alright, there's my graph, and I'm kind of done. Just keep in mind that the highest value to the x-axis should be somewhat the same as the lowest value to the x-axis. Because maybe we're going up 5 to +5 and down to -5. We're going up to +7, down to -7. In fact, in our problem, we're going up to 1/2 and down to -1/2. And remember, it's your scale. Don't say, oh, 1/2, oh my, or 1/2, 1/2, oh my. 1/2 needs to look like that. Nonsense, it's your scale. Why on earth are you calling 1/2 there? Why don't you call that 1/2 and this -1/2, so then you can draw a nice big tall cosine graph. It's your scale. You get to say what the values are on that y-axis. It's your scale. Okay, just like each and every sine and cosine graph, we start where the angle equals 0. This must be -pi. -pi plus pi is 0. If you don't believe it, take away pi from both sides. It cancels on the left, and you're just left with 3x. 0 take away pi is -pi. Like I said, this must be -pi. -pi plus pi is 0. Divide by 3 and you are done, because now we know we start at -pi/3, and we even have our phase shift. Phase shift is where you start. Okay, that's done. We have the start. It starts at -pi/3. -1 pi/3. Because I suspect we're going to need the -1, because we're going to ignore the pi/3. We're going to ignore the pi/3. We have -1 pi/3. Okay, it finishes, the graph finishes whenever the angle is equal to 2 pi. That must be pi. Why? Because pi plus pi equals 2 pi. Don't look at what's in the circle. That's what's making it complicated. Pi plus pi is 2 pi. And if you take away pi, you'll see it. But you need to start for seeing the future. You need to start thinking, what plus pi equals 2 pi? Oh, pi. The future being this line right here. What plus pi equals 2 pi? Pi. Whatever this is, easy looking, hard looking, whatever, it equals pi. Okay, divide by 3, you get x. Divide the other side by 3, you get pi/3. So this graph finishes at pi/3, at 1 pi/3. what's in the middle? What's in the middle of -1 and +1? Because I'm ignoring the pi over 3. What's in between -1 and +1? 0. 0 what? 0 pi over 3's. But that's 0. That's 0. So not only do I know that's 0, I know where the y-axis is, which is great. It's like for free. Okay, what's in between 0 and pi over 3? Well, think of 0 as 0 pi over 3's. And the other one is 1 pi over 3. Ignore the pi over 3's. What's in between 0 and 1? The half. If you don't know that, add 0 plus 1, get 1, divided by 2. That's how you find the middle. You add two numbers up, divide by 2. So in the middle, we're going to have half pi over 3. 1 times pi is 1 pi over 6, or just pi over 6. Pi over 6. If you see symmetry on the left, you'll realize that that value right there is just negative pi over 6. Okay, if you don't believe me, you have 0 pi over 3, and you have negative 1 pi over 3. Ignore the pi over 3's. What's in between 0 and negative 1? Negative a half. Add them up, get negative 1, divide by 2. Times pi over 3. Well, that's negative pi over 6. Alright, so now we have the 5 quarter values. The last thing we need to do, or one thing I failed to do, is you should always label your axes. And the highest value is this number without the sign, a half. And the lowest value is negative that number without the sign. It's negative a half. There it is. Finding the quarter points, that's the whole job. Graphing it is not. Graphing it is no part of this job, other than knowing how to graph a sine graph and a cosine graph. And if there's a minus in front, you draw it upside down. Okay, so graphing is nothing. And if it is something, you need to practice that. Okay, you need to know the following basic things, or things. You need to know that a positive sine graph looks like this. A negative sine graph is just upside down. You must know this. A positive cosine graph goes like this, and a negative cosine graph goes like this. And there's the x-axis. Unfortunately, maybe this wasn't the best time to put this up, because I'm going to contradict that a little bit. The graphs we've done so far were in this form. Maybe you were asked to graph, and again, when I say graph, I mean one period. Graph one period of this graph. I've asked you things like that. Possibly I even asked you to draw exactly that. I think I asked you to draw exactly that, but without the 2 in front. But now, I'm going to be a pain. I'm going to add a constant on the end. That changes it a little bit. I mean, since it's a positive 2 sine graph, the graph will look like this. The problem is the x-axis won't be down the middle anymore. I'm glad I said down the middle. Right here, the y value is 0. And up here, we'll call that the middle. And right here, you have the high, which is 2. I'm assuming for a moment there's no 4 here. The lowest value, well, that's the low. That would be negative 2. But you know what we're doing with every point on this graph? We're raising it 4. The high, H for high, the high normally is at 2. The middle is normally at 0. And the low is normally at 2. Excuse me, negative 2. But somebody's adding 4. So we have to add 4 to every y value. And now it turns out the highest value is 6. The lowest value is 4. And negative 2 plus 4 is 2. So the lowest value is 2. So if this here is the x-axis, and just temporarily, we assume that's the y-axis, temporarily. Well, I didn't realize all values were positive, so let's lower this. Only so I have more room to draw. Let's lower this. Okay, so 2 is the low, 4 is the middle, 6 is the top. Think of this as the x-axis. Think of this as the x-axis and draw a positive sine graph. Okay, here's my positive sine graph. Oh, the highest value should be 6 and the lowest value should be 2. There's my sine graph. I just added 4. Instead of going from negative 2 to positive 2 with 0 in the middle, I add 4. I add 4. And what I have here is exactly what I said here. I add 4. And I get high is 6, middle is 4, low is 2. Okay, now again, that vertical line I drew, that may not be where the y-axis is. It'll be unusual if we're right, because we randomly picked it. Okay, let's find the start and the finish. It starts when the angle is equal to 0. Well, that means it starts at pi, because pi take away pi is 0. Okay, that's pi. It finishes when the angle x minus pi is equal to 2 pi. Well, 3 pi's minus an understood 1 pi gives you 2 pi. That is, it finishes at 3 pi. Okay, not a problem. It finishes at 3 pi. Now, I want to know this x value, and this one, and I already know the last one, and I know the first one. Okay, those are the x values I want to know. Well, what's in the middle of 1 pi and 3 pi? Well, what's in the middle of 1 and 3 is 2. Okay, so you have 2 pi. Now, I want to know what goes in the middle of 1 pi and 2 pi. Well, what's in the middle of 1 and 2 is a half. Half what? Half pi. Now I want to know what's in between 2 pi and 3 pi. Well, what's in between 2 and 3 is 2 1/2 or 5 halves. 5 halves pi. All right. Now, the only thing we need to do is figure out where the y-axis should really go. Now, if you look at this distance, which is the same as this distance, it goes from 1 pi to 2 pi, which is a length of pi. But we're starting at pi. Right here is pi. If we go this distance, if that distance is 1 pi, if we go to the left, that same distance will be at 0. Okay, we'll be at 0. Like I said, drawing this vertical line, in my opinion at least, it helped greatly. But no promises that it's in the right place. It probably is not. Okay, the y-axis should go here. Here's 2, 4, 6, You can put any other numbers you want. I mean, don't put 7 here though. That'd be suicidal. I'll definitely take a point off for that. Between 2 and 4, not 7. Right. Let us try one more like this. And I'm not clear what happened on my x-axis. It didn't want to cross the x, but now it does. This is an x. Alright, let us try one more like this. The twist is finding the high, the low, and the middle, and then putting the y-axis where it belongs. You'll probably have it in the wrong place initially. And how do you know when to do it this new way? Is if you have a number times cosine of some angle, but then you add or subtract some number like 1. Okay. So here's the x-axis right here. Let's make believe that's the y-axis. And let's find the highs and the lows in the middle. The high, the middle, and the low. The middle, and ignoring just for this piece right here, the middle is always 0. The low is just this number without a sign. It's negative 3. I think you know what I mean. And the highest value is positive 3. But now we need to take away 1. We need to take away this unfriendly 1. Okay. So the highest value is at 2. That's the highest value, 2. The middle value is at negative 1. That's the middle value. And the lowest value is at negative 4. Okay, negative 2, negative 3, negative 4. And I am to draw a negative cosine graph, as if this is the x-axis. That is negative cosine, huh? Okay, it goes just like this. I hit the highs and the lows. And I want to know the x value right here. That is, I want to know that x value, the x value at that point, which is right there. Not that x value. No. Okay, let me emphasize it a little bit more here. Not that x value. But rather this x value at that point. That is that value. And of course the end point, which seems to be to the right of where I put x. So let's try to fix that. Make my life easier. And this value right here. Okay, so let's find the start. It starts when the angle is 0. Bring the 2 pi over as negative 2 pi. That's where it finishes. I meant to say start. What value, when you add 2 pi, gives you 2 pi? 0. And you can take away 2 pi from both sides. Left side is x, the right side is 0. So we actually know where the y-axis now is. It's at 0. It's at the end point. It happens to be right here. I call that a freebie. It's right there. Okay, now since we already have the y-axis, I can mark it to negative 4, negative 1, negative 2. I can label them 1, 2, 3, etc. So now I can get rid of my temporary axes. Okay. Now we need to find what? We need to label the points. Okay. I I know that their start is at negative 2 pi. And I know that the finish is at 0. What's in between 0 and negative 2? Negative 1 pi. Let's find this value right here. What's in between negative 2 and an understood negative 1? Negative 2 plus negative 1 over 2. This is negative 3 over 2 times pi. Negative 3 over 2 pi. What's in between negative 1 pi and 0 pi? Half of it. Negative pi over 2. What's in between 0 and negative 1? It's negative 1/2 times pi. That's what I put. That finishes the graph. We have the x-axis labeled, we have the y-axis, we drew the graph, and we found the x value for the point here, the x value in the center, the x value at the end, and those other two center points or quarter points. Those 5 points you should know how to find. Ignore what's common. If you have 3 pi over 7, if you want to know what's in between 3 pi over 7 and 11 pi, so let me write pi over 7. This is 3 pi over 7. This is 11 pi over 7. What's in the middle will be something times pi over 7, unless it reduces. What's in between 0, 3, and 11? Well, add them up, you get 14. The average is divided by 2 is 7. I didn't rig it this way, but you get 7 pi over 7s, which is just pi. It just happened to work that way. Okay, ignore the hardest part. Just deal with the 3 and the 7. Excuse me, the 3 and the 11. Alright, good luck with these graphs. In the next video, we'll talk about how to graph tangent and cotangent graphs. Good luck.